Namaste to all my dear students. How are you? Again, we are going to discuss about the nature of the hydrogen bond, application of the hydrogen bond, and why we study hydrogen bond. Yes. So at first we have to know the nature of hydrogen bond. So always keep in mind those compounds which possess what to say hydrogen bond have slightly high melting point, boiling point, and solubility in water. So always keep in mind. So when we talk about the nature of the hydrogen bond, what do you see over here? So those compounds which possess hydrogen bond have slightly high MP. MP means melting point, BP means boiling point, and solubility in water. So what you see, it has, when we talk about the energy of the hydrogen bond, so what's very weak? The bond energy, better to say, bond energy of hydrogen bond is very weak. I have already told you, very weak with respect to ionic and covalent bonds. So keep in mind. So what you see, 4.5 kilocalorie in case of water, 1.3 kilocalorie in per mole in the case of ammonia, and what you see, 0.7 kilocalorie per mole in the case of hydrogen fluorides. So what you see, with respect to 100 kilocalorie per mole of covalent. So always keep in mind, so generally ionic compounds have more energy, then covalent bond has lower energy. But when you talk about the hydrogen bond, is very, very weak. So what is it? 4.5 kilocalorie per mole in the case of water, 1.3 kilocalorie per mole in the case of ammonia, and 0.7 kilocalorie per mole in the case of HF, with respect to 100 kilocalorie per mole of covalent bonds. Covalent bond is also very weak, but stronger than hydrogen bond and weaker than ionic bonds. Ionic bond has I will talk later about the what see ionic bond, covalent bond, coordinate bond. That time I will discuss what see in detail. So we have clear so what the nature of hydrogen bonds. So those compounds which form or possess hydrogen bond have slightly high melting point, boiling point, and solubility in water. Next, bond energy of hydrogen bond is very weak. I have already told you. With respect to ionic and covalent bonds, suppose data is like this. So 4.5 kilocalorie per mole in the case of water, 1.3 kilocalorie per mole in the case of ammonia, and 0.7 kilocalorie per mole in the case of hydrogen fluoride, with respect to 100 kilocalorie per mole of the covalent compounds. Yes, so very weak bond. So I think you have clear what are the nature of the hydrogen bond. Next one is application. So on the basis of these points, some important what's the application or effect of hydrogen bond in the compound, we can say in molecule. So next title is like this. Applications. Generally application or effect of hydrogen bond in the compound. Yeah, sometimes ask you, so give reason. Sometimes ask you, give reason why. First one is water is gaseous water is liquid state but what is hydrogen sulfide is in gaseous state. Give reason. So why water is liquid state but H2S is in gaseous state? Explain. Give reason. So what you see when you talk about the water, so water forms what you say intermolecular hydrogen bond, so associate to each other tightly. So water is in liquid state. But when you talk about the H2S, but in the case of H2S, hydrogen sulfide gas, there is no intermolecular hydrogen bond. So they do not associate to each other tightly. So it is in gaseous state. Yes, so we have clear. So when we talk about the water, Yes, oxygen. So what is it? Slightly negative, slightly positive. So what is it? Intermolecular hydrogen bond. So due to presence of intermolecular hydrogen bond, molecules associate to each other tightly. So it is in liquid state. But when you talk about the H2S, in H2S, that is the H2S, hydrogen sulfide. Hydrogen sulfide. What do you see over here? It does not form hydrogen bond, intermolecular, any type of hydrogen bonds. So they do not associate each other tightly. So it is in gaseous state. So degree of freedom is high over there, but degree of freedom in water is low. Why? Due to presence of hydrogen bonds. First application, or we can say give reason. Sometimes I ask in examination. First one, water is liquid state, but H2S is in gaseous state. Next question. Next application, we can say second application. Water has higher boiling point than H2S gas. So I have already told you. The answer of this question is because water forms intermolecular hydrogen bond, so they associate to each other tightly. So they need more heat energy to break hydrogen bond. So it has higher boiling point than H2S. Yes. So reason is, but H2S does not form hydrogen bond, so it needs less heat energy. So it has low boiling point. I think you have clear. So why water has higher boiling point than H2S? Second application. Third application is like this. Third application. So what is ammonia? Ammonia is highly soluble in water, but phosphine gas soluble in water, but phosphine gas is insoluble in water. Soluble in water. So the question is, answer of this question is ammonia. Ammonia forms hydrogen bond with water molecule, so it is highly soluble in water, but phosphine gas does not form hydrogen bond with water molecule. So, we have clear reason. So, what you see, ammonia forms hydrogen bond with water molecule, so it is highly soluble in water, but phosphine gas does not form hydrogen bond with water molecule. So, it is soluble in water. Yes. Yes. So, what you see, ammonia, H, that is the water, that is ammonia, that is the water. So, what has slightly negative, it has slightly positive, that is the hydrogen. Always keep in mind. So, those chemical substances which form hydrogen bond with water, they are generally soluble in water due to hydration, yeah, solvation we can say. But when we talk about the phosphine, that is phosphine gas, formula is PS3. PS3 does not form hydrogen bond with water, so it is insoluble in water. So, I think you have clear. Why ammonia is highly soluble? Because it forms hydrogen bond with water, but phosphine does not form hydrogen bond with water. See what I have already given you language. Yes. Next application is like this. So, phosphine does not form hydrogen bond with water molecule. So, you have clear reason. Now, fourth application is like this. Fourth application. So, explain, sometimes ask you why ice has lower density than liquid water. So, you know, when water freezes, what is it change into the ice, you know. So, by the study of X-ray diffraction, so what you see, so by X-rays diffraction method, it was seen in ice, there is open loose cage like, you know, pizra. So, loose cage like structure with large vacant, it means vacant space, it means it has higher volume. We know density is equal to m by, you know the relation of D is equal to m by V. D means density, m means mass, V means volume. If volume is increased, what it means? Density is what is density, and when we talk about the relationship of density and volume, so just inversely, if one increases, other decreases. If increases, so what is in this case? Volume increases, so density is lower in this case. Yes. So what you see, density, it means higher volume. We know D is equal to m by V. So its density is lower. Oh. So when I have already told you what you see X-ray diffraction, what you observe in ice case, suppose that is the ice, so that is oxygen atom. That is what you say hydrogen atom. So it forms what you see delta minus, delta plus, that is oxygen, that is hydrogen, delta plus delta. So it forms hydrogen bond and looks like a cage, we can say. So what you see? So what you say? It has delta plus, it has delta minus. Likewise, so what you see oxygen? So what you see? Oh, hydrogen atom, that is the oxygen. So that is what you see slightly negative, that is slightly positive. So like this, hydrogen has slightly positive, oxygen has slightly negative. You know why? Oxygen has 3.5, hydrogen has 2.1. You know that is all are the hydrogen atom. The smaller one is hydrogen atom and larger one is oxygen atom. So what you see over here? That is hydrogen bond. So what is the cage-like structure? So what type of a structure over here? Cage, the pizza. You know, cage-like open structure. Due to, you can say, due to cage-like open structure, it has higher it means it has lower density. So I always keep in mind it has always what you see lesser density. Why? You know the relationship D is equal to m by V. So what the relation between the density and volume? Inversely, If one increases, another decreases. So what is the volume increases? It means what you see? Density what it decreases over here. So due to cage-like operate structure, it has higher volume. It means it has lower density. So I think you have clear why ice has. When you talk about the what you see water, what you see negative charge, that is what you see hydrogen has positive charge, negative charge, that is hydrogen bond. What type of hydrogen bond? Intermolecular hydrogen. So it associate to each other, and so it is due to presence of intermolecular hydrogen bond, they means what's molecule, they associate to each other tightly. It means it is in liquid state and it has higher density. About this maximum density, you know, water abnormal character. So water has abnormal density, you know, what is 1 gram per cc, the maximum. So we have already studied in physics. So water has abnormal density 1 gram per cc. It means what you see when you increase the temperature, when you decrease the temperature, in both cases what you see its what's density decreases. So maximum density of water is 1 gram per cc. Yes. So you have clear. So I think you have clear. So what is the hydrogen bond, type of hydrogen bond, criteria for hydrogen bond, nature of hydrogen bond, application of hydrogen bonds. So these are very, very important for knowledge as well as examination view of point. Yes. So thank you for watching this interesting video, and I think you have already subscribed and convey students, friends to what you see for learning. Yes, that is okay.